we started yesterday with, here's what makes two polygons similar. Now we're going to go into, here's what makes two triangles similar, and it shortens it up. So as of yesterday, right, this is everything from yesterday. Talking about, if I needed two shapes to be similar, two polygons, I wanted all of the corresponding angles to be congruent, and I wanted all the sides to be in proportion. And every time I would have asked that question yesterday, like if I gave you two shapes and I said, are these similar? I would have expected all that work. And really that's what you would have had to do, because that's the only thing you had. Now, if you take all that and move it into a triangle, like with congruency, there's less that you actually have to show in order to say that these two shapes are similar to each other. Okay? So if we ever have a problem and they aren't triangles that you're dealing with, and I say, are these polygons similar? You still need to do all this work. It's just with the triangles, less to do. Okay, so.
Oh.
You write it?
Oh, I did. Sorry,
Wow.
again. No, I forgot we wrote it yesterday, so we started writing. Oh, no, I didn't.
All right, so with the congruency stuff, okay, we had four main ways to show triangles were congruent to each other. Okay, don't forget those, right? And when we did congruency, we had side, side, side congruency, we had side, angle, side congruency, angle, angle, side, and angle, side, angle. Those are the four main ways. Of course, there's that HL that you use very sparingly. Similarity ones are labeled pretty much the same. Okay, and that's why when we did things like with congruency, I told you, if you did congruency, make sure you very clearly put that mark after it. And the reason is, in this section here, we're talking about triangles being similar. I'm going to have a theorem that looks exactly like that. The difference is it's going to have a little similarity thing as opposed to that. You have to decipher between the two because they mean two different things. One means the shapes aren't the same size, the other one means they are. Okay, so the three that are up here, there's only three, but they're the exact same ones that you did with congruency. The reason that there's only three here as opposed to four is because this first one, angle, angle, takes into account both angle, angle, side, and angle, side, angle that we did with congruency. Okay? The reason you had the side length back in chapter 4, congruency, is having congruent sides meant that the shapes were the same size. Here I don't care about shapes being the same size, I care about them being the same shape. Two angles being congruent in a triangle means the triangles are going to be the same shape. Okay? Which in turn is going to make the sides be proportional. So as long as you have two angles that you definitely know are congruent, well, two pairs of angles, then you know that those triangles have to be similar to each other. Like, there's nothing else I have to know. I don't need to know anything about numbers on the sides or anything like that. Right. Now, if I wanted like scale factors or anything like that, then I would have to have side lengths. Okay, but that stuff would be given. This is just simply saying, are the triangles similar? If you got two angles that are congruent, it would be yes. And guys, you're still looking for things like vertical angles to be there, like a reflexive angle will pop up now. Alternate interior angles will still pop up with these things. So everything that we would have done on that common sheet, like the common figure stuff from chapter 4, that still applies to here. Reflexive sides can still pop up. Okay, all these things can still pop up. Right? So this takes into account through the postures that we did back in chapter 4. Okay, the other two obviously would be side angle side, right? And then side, side, side. The difference between these now is that when I say side angle side in this case, now I'm not talking about two sides being congruent, I'm talking about sides being in proportion. So if you actually have side lengths, now you're still setting them up just like you would have yesterday into proportions, right? And reducing it, making sure it ends up being the same fraction, that kind of stuff. It's just you don't have to do every single side every time for triangles like you would again. Alright, and then of course the last one will be side, 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 which just means this would be the one where you know absolutely nothing about the angles. I don't know if this is a congruent angle, but I have all my side lengths given. And if I have all my side lengths given, and I put them in ratio with each other in terms of like corresponding sides, like all the corresponding sides make a ratio. Alright, as long as they all equal the same, then that's enough for me to say that the triangles are similar. Here's the thing, when you're doing these two, okay, this one here, and this one here, alright, the side angle side and side, side, side. For both of these, you have to do something with fractions there, and you have to reduce those fractions. When you set these up, sometimes it's hard to decipher exactly where the corresponding sides are, especially with this one, okay, because the triangles might be turned or anything like that. What you want to do is always match like biggest side over biggest side, smallest over smallest, middle over middle, in terms of what they are in relation to their own triangle. So you would want to take like the smallest number on this triangle, put it in ratio with the smallest number here. Biggest number of this triangle in ratio with the biggest number here. Alright, and those will always be your corresponding sides, and when you set them up, that will always work. To check to see if they're all equal the same thing when you reduce those fractions. Okay, so you don't, you know, I bring it up because a lot of times the triangles will be turned. You can't just look at it and go, oh, these correspond. They might have it flipped. You might not be able to definitely see it right away. Especially if all the numbers are really close, then it's going to be hard to tell. Okay? Alright. Now, I also, the way I have these listed is in order of least amount of work to do, most amount of work. And that's probably how most of your brain's going to work anyway. Like, if I'm doing a problem and I want to see if two triangles are similar, first thing I'm going to do is I'm going to see if I've got two angles that are congruent. That takes the least amount of work. I mean, at the most with this one, you might have to do something with like either alternate your angles, or you might have to add two angles up and subtract them from 180. That's not much. Okay? This would be the kind of middle amount of work because you actually are doing some kind of ratio, but you're only doing with two sides. Okay, two pairs of sides. And this one down here is the most work if you're using all three sides. And in terms of like how you guys are probably going to think, you're probably going to think shortest way to longest way. Okay, when you're working. Right? And in most cases, you know, you'll have your choice on which one to do. Okay, but sometimes like you'll have to opt into this one. Sometimes you'll have to do this without any doubt. Alright, like if I didn't give you any side lengths, you have no choice but to use this one. Okay, if I give you all the side lengths, then do that one. Okay, now, can I go past this? Yeah. Okay. So these would be just quick examples. All right. I know 2 and 3 necessarily do not have side lengths on them. If you want me to put numbers up there, I can. It doesn't really affect anything. So I'm going to treat them as if the numbers aren't there, but there are congruency marks there, which let me know certain things. But when we get there, if you want me to do numbers on it, I can put them on there. But I'll start on the left, going left to right. Number 1. If you saw that picture, right, I don't have any side lengths. There's no congruency marks on the sides. So that means my only option for me to say if these two triangles are similar would be that, right? Because I don't have any sides, so I can't do side angle side or side to side. They give you one pair of angles congruent, so I've got one of the angles. Is there another pair of angles that's congruent up there? What? Yeah. Vertical. That's enough. I'm done. Those triangles are similar. I got 2 angles that are congruent, 2 pairs of angles that are congruent. So now I would go, okay, since I know that they're similar to each other, then I'd write out my similarity statement. So ABC similar to DE. Okay, fine. All right. What about number 2? What do you think? Yes or no?
No,
Why not?
it's not enough information.
What's missing?
More sides and more angles.
Yeah, I don't have anything on this side, right? So I can't do this one. So that means I have to have all 3 sides, but I only have, the only marks are those right there. All right, and I can't do this one because I don't have any angles that are congruent. The only thing you would know up here is that these 2 angles are congruent, those 2 are congruent. Which usually gets people, and the reason they're congruent, right, because these are isosceles triangles. And some people will do that, and they'll go, look, oh, there's 2 pairs of angles, but there aren't. The pairs of angles are within the actual triangle. Screws everything up. You can't do that with it. Okay? So this one is a right now. Alright? What about this? You only put numbers on this one because this one usually throws people if I don't. You want me to put numbers on there?
No.
No? Fine. We'll do that. This is all you got is these congruent marks right there. You're saying that, where's the angle at? And the 2, if you don't see it, guys, the 2 triangles I'm talking about, just so you know, this triangle here is the empty triangle L, and then the big.
Well, I guess not. I was thinking distance and like the same angle on both.
M is in both the triangles, okay? Since M is in both the triangles, angle M being congruent to angle M because of that reflexive property, right, which is congruent to itself, that gives you the one angle. That angle is in both of them, and it's in the exact same spot in both of these triangles, so that works for this angle. The other thing is, if I'm doing side angle side, are these sides in proportion to each other? Yeah, you think? This is where I would do the numbers just to make sure. Okay? So if I just put like a 2 there, and 3 here. When I match these up, right? When I match these up, guys, especially with one like this, very clearly understand that the sides of my triangle are this side and this side. So when you do your proportion, if I gave you numbers on a problem like this, you would do like 2 over 4, not 2 over 2. Okay? So over 4, and then on this side you would have to do 3 over 6. Okay? So 1/2 equals 1/2. So that would be fine. So that would mean that those 2 sides are in proportion. I got my congruent angle, so this is a yes. I know that this triangle right here is similar to that triangle because of side and side. And like I didn't have to do the numbers there. Like I could see both sides were split in half, so that definitely makes it proportional. You could actually, there's other options. You could have used on 3. You could have realized, just to go back into other things, you know, you also could have realized, hey, that's a midpoint, that's a midpoint, that's a mid-segment. It's a parallel because it's a mid-segment, which makes those angles congruent right there. So there's angle, angle. I could have used that, but I would have had to add all that explanation. Okay? That is an option. All right? Now, what you guys do before I get into the other problem? Let's get that. And then, like for this one, should have been angle, angle, you've got, right, alternate interior angles to use right there for your 2 angles. 8, sides are proportion to 8 over 10 is equal to 6 over 6. 9, this is a yes answer. Let me show you one thing. If you're just checking a yes or no, you can simply divide these and get okay. Like that's always going to give you a yes answer there. Like in this would be side angle side. Alright, because your angle's here and the sides are in proportion. The only thing you have to be careful of, if I asked you on 9 what the scale factor is, like that wouldn't be right for the scale factor. It would be using what I said on the other thing. Because the two triangles you're looking at involve this side and this whole side, so this wouldn't give you scale factor. You could use that to check whether or not they are. Okay, because if those two divide evenly, it does create two triangles that are similar. When you do scale factor, though, you would have to use that entire side that's 36. So if I, like on 9, I said, what's the scale factor? It would be 36 over 24, which is 32, not 2 over 1 or 1/2 or something like that. Okay, so just kind of keep that in mind if you see one triangle inside the other. Okay, and then this part only matters, like if I took it one step further and I said find like this value and you had a number here. If you had to find the actual side length, that's where that scale factor comes into play. All right, then on 10, I think 10 was a no. You would do like 40 over 60, then it would be 30 over 45, and it would be 22 over 32. Which these aren't all equal. This is definitely, I can tell it's not equal to the 2/3 thing. This one here, this is a no. This angle right there is 120. Find it, or you can find this one being 35. So either way, you could see it. It doesn't matter which other angle you found. You would realize that there's only one congruent angle, which is the 235. Then you wrote 12. Again, there that is all. Yes. All right, and really with the ones that were yes, you should have done the similarity statement. So 7's right. 12, the similarity statement there with ACB, similar to. And then this one up here would be, like 9 would be PS, Q, and RS. Okay? Yeah.
Now the photos ABC equal H 13. Okay.
All right. Now, the last bit of this, guys, is just doing problems like we were doing yesterday with finding side length. Actually, we do this one first. We do this first, I'm gonna come back. So that I'm gonna the indirect measurement I'm gonna leave it as the last. So like the other thing would be solving for x's and y's, which is the whole using similar triangles. But this is the same as any problem you would have done yesterday with knowing, hey, these shapes are similar, therefore I'm going to find side lengths using proportions. Same kind of idea here. Just in this case, I don't necessarily have to say in the directions these are similar. Because now you can look at it and go, I've got two pairs of congruent angles there. That means because of that option, I know that those two triangles are similar. So I know that triangle OMN is similar to triangle HGI. And I can say, okay, since I know they're similar, now I can go ahead and set up proportions to solve for those x's and y's, but you would treat it the same as yesterday. Like you would go in there and match up corresponding parts. Like I know x, this side right here corresponds to which one of the other triangles? 10. So I would do like x over 10 equals, and then the other side, remember, you want two sides that correspond that actually have numbers on them. This would be your 16, 12. Okay? Another thing you can do, if you don't want to use like the larger ones, like the 16 and 12, if from the get-go you want to like find the scale factor, right? And the scale factor is 16 over 12 reduced, right? If I reduce 16 over 12, that's 4 over 3. So instead of doing that, if you want to use the smaller numbers, if you have multiple variables to solve for, it's usually easier to get the scale factor first, and then just stick the scale factor into the other side. Because then you're dealing with smaller numbers. So you'd end up with 3x equals 40, so x is 0. Yeah. right, and then, so setting up for the y, we do like y over, which one corresponds to y? Which one? 8. And then on the other side, if I've got the scale factor already, I'm just going to use that because it's a smaller number. Again, it's not necessary that you get to do the scale factor first in a problem like this, but I'm just saying solve for x and y. It's just, if I've got multiple variables, especially if I give you one that's got like 3 variables in it, it's usually easier just to find the scale factor first and use that number repeatedly over and over again. Because it's going to be a smaller number to work with, smaller number of things to multiply are generally easier to deal with because then you don't have to necessarily use a calculator. The larger the numbers, the more you're going to rely on a calculator to do the math for you. Okay? Now, the thing that I skipped, I'm going back to, the indirect measurement thing. It's the same concept as this. All right? The exact same thing where you're solving for a variable. The difference between them is with these, it's going to be some kind of word problem. All right? But I think most of them have a drawing there so that you can actually visualize it. But the whole deal with the indirect measurement, like what this is talking about someone placing a mirror on the ground, looking down at it, and when they look down, they spot the top of it. And basically what happens here, in an ideal situation where you're dealing with both of these triangles being right triangles, in essence, you're creating 2 similar triangles. So since the triangles are similar to each other, and this is how the indirect measurement works, is you are creating these similar triangles so that you can then find the value of this right here by doing a proportion. And I know I can do a proportion because these 2 are similar. And they're similar because I got 2 angles congruent. 2 angle makes together. All right, so it's just a matter of you recognizing the fact that you have 2 similar triangles and then just setting up the proportion accordingly. Okay? All right, now here's the thing with this one. Since they have a measurement over here that has feet and inches in it, that means I either need to convert everything to feet or everything to inches before I do the proportion. What do you want to convert them to, feet or inches? Inches? Fine. Okay, so 5 feet, 6 inches. Someone tell me how many inches that is. 4 feet is how many? What? 48, and then 10 feet is 1. So when I actually set this up, now I'm going to do it in the manner of, I got to find x, which side corresponds to this x right there? 66. And on the other side, I would have the 120 on top, because that's the side that's with my x, like that's on the same triangle. And then 48 would be on the right? I could reduce if I want. It doesn't really matter. I would assume most people are probably going to pick up the calculator for this anyway. So what's 120 times 66? Do with the larger numbers. And then divide that by 48. So this would be 165. And then if you're doing a problem like this, guys, make sure you include the units so that you definitely have the understanding of what type of measurement you're doing. If you wanted to convert it back to feet, you could. It's just not a necessity unless the problem directly says make sure your answer is in feet or make sure it's in meters or something like that. Otherwise, it wouldn't matter. Just make sure you put the proper unit at the end or whatever unit you were using at the end of it so I know it's correct. But anything that looks this way, guys, anything where they reference indirect measurement, it's just 2 triangles that are similar. That's it. You set a proportion. Okay? Don't overthink them. Don't think it's some weird thing you have to do. It's just a proportion. And a pretty basic one, actually. There's not even anything to distribute. Okay?